Hi everyone, welcome back to Statistics and Data Analysis. Today we will talk about a new topic which is called regression analysis. Okay, regression analysis. In some sense, this is one of the most important statistical technique. So I hope you will really learn something from these 2 weeks because it's just important. Okay, so in this video I will give you the overview of the topics, and then in the next videos I will start to talk about simple regression, and then I move to multiple regression, which is a little bit more complicated, and finally we go back to study how a model is really useful, okay, about validating a regression model. So the topic here is that we typically want to find the correlation among variables, right? Just as the example that we did in the very first beginning of our of this course, we talked about the relationship between prices and the sizes of houses. For example, here we collect a set of sample data for 12 houses. For each of them, we get their size and the price. So we get two vectors of numbers. Each vector has the length 12. We know that there is something called correlation coefficient. And in this particular example, we can calculate that as 0.729. Okay? If we are using R, there is a function called COR, or if you are using Excel, there is a function called CORREL. You look up the manual, you can easily calculate the correlation coefficient. Now, here we have the first question. Suppose now I have a new house, or I collect the new information about a house, and I know that house, the size is 100 square meters. Okay, 100 square meters. If that's the case, how may we somewhat predict its price? Okay, I certainly know that price and size has correlation, has some relationships. I even know that the correlation is highly positive. Okay, the correlation is very strong. But even with that information, how may I make some predictions from size to price? Okay, that's the first question we want to ask. And also, sometimes we may have more than two variables. For example, another set of information that we may collect, for example, is the number of bedrooms in each house. Okay, for each house we know how many bedrooms does it have. And in some sense, the number of bedrooms may also affect the house price, right? So that information may also be related to size and price. So if that's the case, may we somehow summarize the correlation among three variables? Okay, this is definitely something we did not cover when we talk about correlation coefficient. If you go back to check the formula, that formula can only accommodate two variables. If we have more than two variables, then that's another issue. And also, once we have their correlations, may we predict house price based on the size and the number of bedrooms? And that's another question. So in general, when we have that kind of problems regarding more than two variables and regarding prediction, then the regression analysis or the regression model is really what we want, or really what we can use. Okay, and you can see that task is so important, and that's why regression is used by almost all the statisticians and data analysts. Okay, so regression, I believe, should be one of the most widely used tools in the world of statistics. A regression model will discover the following things. First, which variables really affect a given variable the most? Okay? in some sense, if we are talking about one variable, there may be multiple factors affecting the behavior of this variable, but we want to know what are the most important key factors that can be answered by regression. Or when we want to talk about how do these key factors affect the target, then again, the regression model can give us an answer, or at least a suggested answer. Okay? So whenever you want to ask what affects this outcome, okay, what make this outcome appear, then you need regression. If you want to ask why our product is unpopular, or if you want to ask why our factory is out of control, or you want to ask why students do not have good grades, okay? Whenever you want to find factors that affect an outcome, you may use regression. In general, we will predict or estimate one so-called dependent variable by one or multiple independent variables. For the outcome, we will call it the dependent variable, like whether consumers buy it or not, whether our production process is under control, whether students get good grades. Okay? For the outcome, for the result that we care is a dependent variable. And then for those potential factors that may affect the outcome, they are called independent variables. As an example, suppose we want to predict the demand volume or the number of arrival consumers for tomorrow. Then the dependent variable will be simple. It's just the number of arrival consumers. Or sometimes we may use, let's say, the number of sales as an indicator. But anyway, that will be some variable whose quantity can be verified. And then we have other variables that may affect the dependent variable. Those independent variables may include, for example, weather, holiday or not, whether tomorrow is a holiday, whether we have a promotion event for tomorrow, or whether my competitors have a promotion or not, something like that. Okay? We can, based on past data, to relate these independent variables with our dependent variables. Those experience will be used for predicting what's going to happen tomorrow. In general, regression analysis is very useful. It can also be applied in all kinds of business scenarios. In the lecture time, we will give you some more examples. But in this particular lecture, in this video, I only want to give you the basic principle and concept about regression. So we will stick to the very basic example about house size, price, and the number of bedrooms. Before we really start, let me give you some more terminologies. There are multiple types of regression analysis. According to the number of independent variables, if we have only one independent variable, we call it a simple regression. If we have more than one independent variables, we call it a multiple regression. Based on the assumed relationship, we may have linear or nonlinear regression. As later you will see, when we want to relate independent variables to dependent variables, we need to first make an assumption about how does one variable affect the other. And then based on that assumption, we start to do estimations. Okay? If we assume there are only linear relationships, then that's a linear regression. That will be our focus today. For nonlinear relationships, we do nonlinear regression. In the next week, we will see some examples. In this course, we will only focus on regression models with the dependent variable as a quantitative variable. Okay? Quantitative means height, width, sales quantity, sales revenue, cost, yield rate. Okay, those continuous variables. If the dependent variable is qualitative, okay, nominal or ordinal, like buy it or not, or broken or not, okay, if the dependent variable is qualitative, all those techniques introduced in this course cannot be applied. Okay, you need some advanced techniques, for example, logistic regression, to deal with those kind of problems. So please keep in mind, for this course, our ability is only to deal with dependent variables that are quantitative, or whose values are continuous. Okay, so in the next video, I will start to do the introduction. Thank you.